In this problem, we're going to calculate the boiling point of a solution of strontium chlorate. We're going to use the equation of delta Tb. The increase in boiling point is going to be equal to I times Kb times m. Now we have values of Kb and m. We need to look at the compound in order to determine I. Strontium chlorate is a soluble ionic compound. It's going to dissolve in water, and like all ionic compounds, when it dissolves in water, it's going to dissociate into ions. Now we're going to assume that it dissociates completely into ions, such that when it's done, there is no remaining strontium chlorate. Instead, we have only strontium ions and chlorate ions. So what we see here is that each unit of strontium chlorate is going to dissolve and subsequently dissociate to form 1, 2, 3 units of solute. So our Van 't Hoff factor is going to be 3. Each unit of our solute will produce 3 particles in solution, 1 plus 2. So we've made our substitutions. Our I is 3. Our value of Kb is given to us in the problem. And our molality, again, is 0.90 moles per kilogram. Looking at the units, we see units of kilograms cancel and moles cancel. And our answer is going to be given in degrees C. So we've done our multiplication. But we're not done because we've calculated our value of delta Tb, so we have to add delta Tb to the boiling point of our solvent, which again is water, to get the boiling point of our solution. And here we have our final answer for the boiling point of the solution. The initial boiling point of the solvent, since our solvent's water, it's exactly 100 degrees C. We're going to add the delta Tb. We can justify just 2 sig figs in our delta Tb, so that results in a final answer of 101.4 degrees C for the boiling point of our solution. Now for this virtual lab, you're going to measure the boiling point of a solution experimentally, and then calculate the expected value for the boiling point of your solution. You'll need to calculate the molality of the solution from the mass of your solute and its formula weight, and I you will need to determine based on 100% dissociation of sodium chloride. Then you're going to compare these two values.